Okay, good afternoon to all IEM and UEM family members. Today's topic, a big one, it appears performance analysis of a solar thermal air conditioning, okay, STSC system using three-stage vapor absorption technique. And the part one is solar thermal system, potential applications and its system selection procedure. Seems quite a bit. Anyway, it is to be presented by Professor Iqbal Ahmad from the Department of Mechanical Engineering of UEM Jaipur. His camera is not working, but he is there. So, Professor Iqbal, you may kindly take over.
Yes, sir. Thank you, sir. Thank you so much, sir. First of all, I would like to thank our Chancellor, sir, Vice Chancellor, sir, our Director, sir, Dean, sir, and Provost, sir, and my HOD for giving me this opportunity to present this topic, performance analysis of a solar thermal air conditioning system. STAC system using three-stage vapor absorption technique. Okay, actually this topic is very complex. That is why I divided to present this topic in two parts. Today I will discuss about the what is solar system and its classification, then its potential application and how we can select the certain system. So in part one, I will today I will present solar thermal system, a potential application and its a system selection procedure. Okay, now I'm coming to the next slide. This is the outline. The first we have introduction, then solar thermal energy system. What is solar thermal energy system? I will discuss. Then classification of solar thermal energy system. Then what are the different type of collector? What are the different type of collector? That is flat plate collector, evacuated tube collector. Then I will discuss concentrating solar collector. Then what are the potential application? Now, I will just start this topic with a very renowned scientist, that is Thomas Edison. He said that I would put my money on the sun and solar energy. What a source of power. I hope we don't have to wait till oil and coal run out before we tackle it. So this was predicted by the Thomas Edison that in future we have to depend on solar energy. Now, it is not a new technology. Okay, rather it is used at the very early age. People are using this technology for drying the foods, for drying the clothes, and for drying their grains, and many more applications. Even the people thought about that the sun is just like a god, which eliminates the darkness and send us into the brightness or light. Okay, so that is why it is not a new technology. People have been harnessing solar energy for a long time. Now, why solar energy technology system? We all, many, our senior professor has talked about the solar PV system and its and related things. But this technology, solar thermal energy, was I think not yet discussed. That is why I've selected this topic. Now, what actually the solar thermal system or solar technology system? First of all, the solar thermal system uses sun energy or sun radiation to generate low cost environment friendly thermal energy. And further, this thermal energy is used for producing the power, for cooling application, for different processing application in various industry, in dairy industry, in rubber industry, in textile industry, even in power plant. We are using this process heat. Even in the basic, very general and very common, everyone might have seen this technology application, that is solar thermal water heater, our domestic water heater. Now, this technology, this is the technology and method to harness the solar energy for the purpose of producing electrical energy. Why electrical? Because the electrical energy is one of the most convenient form of energy, which is easy to transport, easy to generate, easy to transfer, and easy to utilize. And again, it is further utilized to provide heating in industrial processes, application, and our daily life, like for bathing, for cooking, and many more. Now, it is very well known there are two uh, way by which we can harness the solar energy. One is the solar thermal method, and second one is the solar PV, that is solar photovoltaic. In this solar photovoltaic system directly produces electricity, as this PV panel is made up of semiconductor which has electron on holes, and with these mechanism, this PV are able to produce this electricity. But as we all know, ultimate goal is to either for running the pump, for heating anything. So here we have another very useful method or convenient method, that is solar thermal system, that is used for basically it is used for water heating and cooking, and we have many more applications. I will just explore one by one. Now, as I've already told, it is this PV energy conversion method is a direct method for converting the solar energy into electrical energy. However, this solar thermal energy is indirect method of power conversion or any type of energy utilization. Now I'm going to the next. Now, how the system, solar thermal system is. Okay, what is the basic necessity of a solar thermal system? Or we can say, what is the basic configuration of a solar thermal system? Okay, now I'm coming over here. A solar thermal system, as you can see over here, we have this block diagram. From this block diagram, anyone can easily understand that we are getting energy from the sun, and this energy, this is the solar, and this energy is collected by a collector. Okay, and this collector, or by the combination of collector and receiver. Okay, now generally we are using the water because it is abundant, because it is everywhere available, and we can also use different working fluid. Okay, so first of all we are receiving the sun energy, and it goes to the solar collector, then it goes to the then it is used. This solar collector are basically a heat exchanger that is used, that solar thermal collector are basically are a special kind of heat exchanger that transform solar radiation into useful heat energy. The heat energy may be extracted from the solar collector by the circulating the working fluid. As you can see from this schematic diagram, here we have the working fluid, then we are having this heating and cooling. We are using this for the heating and cooling application, or we are using for the power generation, or we are using for domestic application, that is for hot water, that is for the boil. In winter season we are using this as a water heater. Okay, hot water heater. Or there are two type of cycle you can see from here. There, one is the closed loop cycle, and second one is the open loop cycle. Okay, so you can understand the case for solar water heating system is just like a open system, because it is the fluid or water is let off. We are just using it, and it is not returned back to the system. Now again, the for the power generation, okay, for power generation or cooling application, the working fluid go throughout this circuit, go throughout this circle. Now there is another block you can see over here. It is very essential. Okay, it is very essential. That is thermal energy storage system. Okay, why we have I have put it over here, because it has great importance. Okay, just think like this. Suppose in our household we are collecting the water at our storage tank. At our storage, we are running the pump for, let us consider, for 10 minutes, and for 10 to 20 minutes for collecting the water, and further we are using it as per our application. Similarly, the same thing happens in case of solar energy. Suppose we don't have this solar thermal energy storage system, then we can only use this solar thermal system during the day, but we cannot use it during the night. Or that is why we have this thermal storage system. This storage system is made up of this phase changing material or different working fluid that can store the heat energy during the daytime, and we can further utilize as per our requirement. Okay, now I'm coming to the next slide. Now again, coming to the classification of a solar energy system. Now, how they are classified? As I have already told, solar energy system are divided into two categories. First one is the solar thermal energy, and second one is the solar photovoltaic. From the schematic diagram, now again the solar thermal energy system are divided into two subsystem. That is, first one is the non-concentrating system, and second one is the concentrating system. Okay, now everyone might have seen this. Here we have this concentrating and non-concentrating. So just the simplest one collect our system, solar thermal system, is that is FPC. What is FPC? This is flat plate collector. And second one is the ETC, evacuated tube collector. Okay, just everyone just can understand from this diagram. Let me just show this diagram. Sorry. Just this is the flat plate collector having the this is the flat plate collector. So just in short, I've written FPC ETC for evacuated tube collector. I will discuss LFR for linear pressure, PTC for parabolic trough collector, CT for compound collector. Okay, and like this. Now again we are coming to this. Now further, this system, as per the temperature requirement, as per the our system temperature requirement or design specification for the process heating and power generation is used. Okay, now I'm moving to the next slide. Now again, here we have the more detail of this system. Okay, now here non-concentrating, we are mainly divided the non-concentrating into flat plate collector and evacuated. Now again, concentrating collector are having the tracking system. Okay, first one is the single axis tracking system. Under the single axis tracking, we have this compound parabolic concentrator. Then we have this parabolic trough collector, linear Fresnel reflector. Then we have two axis tracking system, that is the parabolic disc collector. Now again the power tower. This is having the great application nowadays. This power tower or central receiver are having the great application for producing the power. And in my system, I have used this parabolic trough collector for air conditioning system. I will just discuss. Now moving to the next slide. Now here we have the simplest flat plate collector. Everyone can understand from the schematic diagram. A flat plate solar collector consists of absorber plate, flow tube, glass cover, insulation, and outer cover. Now coming to the it has two very essential parts. One part is the absorber plate, and it is made of metal. Okay, and just you can relate this why we have in the form of metal we are taking the copper, aluminum and steel, because the copper is having more free electron, and these are the very good, this copper is very good conductor, aluminum is also good conductor, also the steel is having some but the copper is mainly used, and aluminum is mostly the copper is used for more efficient system. And again we have the selecting coating over here. Now you can see from this diagram. Okay, so now again the heat transfer fluid, we are using the heat transfer fluid, generally we are taking the water. The heat transfer fluid HTF is circulated through the flow tube to collect the heat energy. The flow tubes are connected with header, just here we have this header, and it is further go to the HTF distribution system, heat transfer fluid distribution system, and further it is utilized for either for domestic water heating and other application or other different application. I'm giving the example of this domestic water heating because everyone is very aware. Now here we have the evacuated tube solar collector. Here the tubes are evacuated, and the energy is falling all on the this cylindrical tube, and this is more efficient, this efficient than this flat collector. Okay, I will also tell what is the temperature requirement, how much temperature this flat plate collector and evacuated tube collector can produce. Now here we have this concentrating solar collector. Now here we have these four type of concentrating solar collector. First one is the linear Fresnel reflector. Here the concentrating solar collector provide heat at relatively higher temperature. Now we can imagine what is the amount of heat over here, or temperature. Just we can understand it, the range of temperature is 150 to 1500 degrees Celsius, which can be used for process heating and power generation. And we have in India this system. We have also in India there is a central national institute that is called NICE, National Institute of Solar Energy, and that have this system that of capacity 1 megawatt. Now again we have the commercially available technology that is available, that is linear Fresnel that I have discussed. Then we have parabolic trough collector. As we all know, in case of parabola, what happens? When the sun rays fall on this parabola, it will focus on a line or on a point. This is the characteristic of a parabola. Now again, we have this central receiver tower. Just here we have this small mirror. Here we have this small mirror, and that is termed as heliostat. And here we have this central receiver on which the steam is generated, and further it is used for running the turbine for producing the power plant. Now again we have this the parabolic disc collector. These are used for cooking food for community cooking purposes. Now moving to the next slide. Now again here we have the some feature of this evacuated tube. Uh, Now here we have this, you can see in more detail over here. Evacuated tube subaqueous is made of parallel row of transparent cylindrical glass tube connected with the header pipe. This the main pipe is called the header pipe. You can see here the cold water is going in, and hot water is coming out. This tube consists of thin glass outer tube and thinner glass inner tube. Now inner glass tube has an absorber plate with flow tube. Now the annulus region, the space between the two glass is evacuated to minimize the convective heat loss. Okay, so this makes the system more efficient, this evacuation. Now again, these are the property of a concentrate of a parabola. When the sun rays fall on a parabolic surface, it focus on a point. Now again, here the technology that we have seen, like this parabolic rotational solid concentrate the irradiance, means solar energy or solar radiation up to 2000 times. Now again, the extruded uh, parabolic profile concentrate the irradiance or solar radiation up to 200 times. So just look at over here. This is the application that is used for this. You can see in the left hand side, this is the application for the central receiver, and or we can say power tower, and this is for linear Fresnel. Okay, what we are doing, we are just dividing in different part, very small part, so that its transportation or design become or installation become easy. That is why it is divided into a small technology, and these are called the Fresnel concentrators. Now again, here we have this application. This Stirling system is used for producing power from 5 to 255 kilowatt electrical energy. Now again, these are the pilot project in India. Now again, the solar tower system. It has capacity to produce 5 to 100 megawatt electrical power on grid or long term pilot plant. These are now again the parabolic trough. These are used and it can produce 5 to 200 megawatt electricity. Now again, the linear Fresnel, it can produce 5 to 200 megawatt electricity. Now again, here we have the different type of collectors are having different temperature scale. You can we can see over here the point or focusing solar collectors are having more temperature than the linear Fresnel. Then again, the compound parabolic concentration. Then we have the evacuated tube. Then the last, or we can say the lowest temperature collector is that is the flat plate collector, and then the just medium range collectors are evacuated tube collector, and this point collector, or we can say the central receivers, are high temperature producing collectors. Now again, what is the relevance and advent of solar heat for industrial process? Uh, Now again, just we all are every day hearing that fuel price is increasing day by day. Now again, now the fuel, mainly oil in India, costly. Now again, the 70% is imported. We can save around 10% can be saved by using this technology. Again, India has large number of de decentralized or unorganized sector, that is small and medium industrial units, where we can easily use this solar thermal system. Again, the process steam require up to 10 bar or up to 180 bar can be achieved by using this solar thermal system. Again, the concentrator needed, that is the fabrication at lower case. Concentration fabrication at lower cost. Cost is we have one time of cost. Okay. Now again, a few innovators and industries took interest in it, and develop it as a business sector since 1998. That is the Seppler, and again that is for the cooking purpose. Again, this is for making. Now again, the very renowned in India, we have this Thermex megawatt solution, or ATE, that is very renowned. This Thermex is used for making solar thermal system, also for making this air conditioning system using this solar thermal system. Now I'm moving to the next slide. Now again, here is a a huge application, huge potential application of this solar thermal system in the industrial sector. We need this much of temperature range for medical industry. We have this much, that is 80 to 30 degrees Celsius temperature is required for, and here we can use the working fluid as a steam and air. Now again in textile industry, that is we can use water or steam. The temperature range is 60 to 150. If we have to before designing, we must have this data, this specific, before designing any system, this we must have idea about this temperature range, so that we can select the proper collector. Okay, now again in chemical industry, the temperature range is again 80 degrees Celsius to 320 degrees Celsius. Now pulp and paper industry, we are using this steam, and the temperature requirement is up to 180. Now the food industry, that is used for now food industry. In food industry, basically we are using the dryer, air dryer, because many food, just like the dry foods, require the we need to dry it. Okay, so here the temperature range is 80 to 220 280 degrees Celsius. Again the mechanical industry, we need temperature range of this much. Now again I am coming to the this hospitality sector. So I have just discussed this. Now in the laundry we need the steam, huge amount of steam. And in conventional form, how we are getting this steam? We need to burn the coal. Either we need to burn the LPG, either we need to burn any conventional fuel, and which will cause a huge amount of pollution or harmful gases that can affect our environment. Okay, so there that is why we can produce this steam for laundry application, for cooking application, and for cleaning and bathing application. We can produce this. We can use this solar thermal system. Now again for comfort cooling, this is my topic, on which I am. This is the topic on which I am working. Just this is in this system we will use the thermal energy of solar radiation to power thermally driven cooling machine, or we can say the name is vapor absorption machine, or we can say vapor absorption air conditioning system. And it is further reversely it is further used for heating application in winter season. And one of the advantage of this solar system for air conditioning is when we have the high demand, or in during the summer, as we all know, there is the very huge demand. And for and also the sun radiation is very high. So what happens, the sun, this is very fortunate, the load and the season or time are matching. That is why the load, that is why this is very popular. This air conditioning system are very popular. And again, in any building, suppose in any building we have lots of appliances like bulb, tubes, and many more appliances. But the and we have also the air conditioning system. So what we have, the air conditioning system itself consume around 30 to 40% of electricity. So by using this solar thermal application, what we can do, we can minimize this overloading on the grid, on the our power plant. Now again, so here we can see the 30% HVA, it is used for HVAC, that means the ventilation and air conditioning system or network. That is contributing around 30 to 40% in the for a building. Now again, I'm coming to the community cooking, because we can think, suppose solar cooker. When we are talking about the solar cooker, when I am only interested for solar cooking, so it will be very difficult. I have to wait, for a larger time. That is why it is this community cooking or cooking at large scale is very popular. Even in Rajasthan at Mount Abu, we have this community cooking system that is used at different hostel and different places where we have the large number of people staying at the same place. So cooking load and time of cooking matching needed, because at the we are generally cooking at the daytime, and it can so again here the time and load is also very uh, positive. Now again, storage, here the storage for early or late cooking, we need to put a storage system. Now different cooking item requires different temperature. Just here I have listed the item that is rice or dal and vegetable. Okay. Now the amount is a per meal intake. Suppose I have taken rice as 10 grams, sorry, 100 grams, and dal as 500 gram, and vegetable of 5 grams. Okay, and the heat required for cooking is around 85 to 90 kilocalorie per meal. And what is the temperature requirement? The temperature requirement is around 120 degree Celsius. The temperature requirement is now again the chapatis. For chapatis, the temperature requirement is now here we have the I have taken for the 25 gram per chapati weight. I have taken for two chapati per meal. It will consume 50 kilocalorie to 100 kilocalorie, and temperature requirement is 280 degrees Celsius. Now for hot water and milk, for 200 ml equivalent, it requires 50 kilocalorie per day, and the temperature requirement is 100 degree Celsius. Okay. Now I'm moving to next slide. Now here I have detailed summary of different sector. Here I have the detailed summary of different sector. Uh, 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 just we can see over here. Uh, just look at over here. The different industry I have listed the in the different column. Here we have the industry, then process, then temperature. Now, fossil fuel power plant, the feed water heating temperature ranges are around 100 to 250, and the steam direct steam injection is this 300 to 500. So these are the different sector where we can use this solar thermal system, whether it is petroleum refining system, whether it is pulp and paper industry, whether it is dairy industry, whether it is beverage, whether it is rice mill, whether it is leather industry. Here the temperature range is given, okay, for different processes. Even for the automobile sector, and again for the metal processing, like for hardening surface treatment, the temperature is given over here. So this much of temperature range we can achieve by using different system. So now you can see how many area it can cover. The application is very wide, so we have to think on it, and we have to work on it actually. Now I'm going to the next slide. Now again, the selection of suitable solar collector, this is very important. Okay, this selection criteria is very important, as I have taken this STSE, solar thermal air conditioning system. Now one of the essential element of a solar thermal air conditioning system is solar collector. Basically, these acts as a heat exchanger, which collect the solar energy in the form of heat, and further heat is transferred into some thermal thermal friendly fluid like water, air, oil, and other PCM. PCM means phase changing material. At last, the collected solar energy may be used for purpose power generation or directly used for air conditioning system. Now again, as I have already told, there are two type of solar collector. One is the fixed or non-concentrating type, and I have already discussed this term. Those collector which have identical septing and absorbing area is termed as non-concentrating collector. Now again, here we have the different type of collector based on their motion and their tracking system. Okay, and different temperature range. Now we are coming to suppose in my case, suppose for let us consider for the sorry let us consider suppose for bathing application we need the water at uh, around 40 degrees Celsius, 40 to 45 degrees Celsius, or lesser than that, or in between 30 to 80 degrees Celsius. For this, we can use this flat plate collector. That is a very simplest one. That is a fixed type of flat plate collector, and concentration ratio is 1. Okay. Now again, this evacuated tube collector, that is over here. That is the again here the concentration ratio is 1, and the temperature range is 50 to 200. Now just you can see. Suppose we need only for the bathing application, then it is sufficient to just use this flat plate collector. No need to go for evacuated tube. And suppose we need higher temperature range, more than 80 degrees Celsius, then we have to go for the evacuated tube collector. So this is the very important list by which anyone can find the suitable collector. Now again, coming to the compound parabolic collector, that is in tubular form, and the concentration ratio is 1 to 50, and this temperature range is 60 to 240. Now as per our requirement, we can select this collector. Now again, we can see this heliostat fill collector, or we can say is having the temperature range of 2000, 150 to 2000. Now again, the parabolic disc collector is having the temperature of 100 to 1500. Now these are the temperature range as per our temperature requirement, and as per our space requirement, we can select a suitable type of collector or solar thermal system, or we can say these collectors are the heart of the this solar collector system. Okay, so these are the this table is very essential for while we are going for the selection of a solar thermal system. Now moving to the next slide. Now again, selection procedure for solar thermal system. First of all, we must have a need. What is the need? Or we have to identify the application. What is the application? For which type of application or for which type of purpose we are using this. So first step over here is the identification of application. Then the next step is we have to think about this. What is the temperature range for this for a given application? What is the temperature range? Then suppose the temperature range is 30 to 80 degrees Celsius. So which technology we have to go for under the solar thermal? We can use this flat plate collector. That is sufficient, that is enough. Now again, we need to go to the third step, that is the selection of suitable technology. That means which type of collector we have to use, either flat plate collector or evacuative collector or parabolic tuff collector or linear Fresnel collector. It depends on our temperature requirement. And now again coming to the collector availability in the market. Is it available in the market? Suppose some collectors are not available in the market. When we are talking about this, linear Fresnels are not manufactured in India. So and that is why it is not. It also depends on the market. Now again, we have to think about the what is the solar field area. What is solar field area? Under over which we need to put this collector, that is called the solar field area. Okay, the land over which we need to put this solar collector. That is one of the again the criteria and we can say this is one of the challenge of this solar thermal system. That is why it is very popular in Rajasthan, and where the land is the availability of land is high, or it is easily possible. So we have to think about this solar field area. Now we are coming to the suppose we have this. Now again, how much number of collectors are required? Okay, suppose we are having this temperature, then what is the capacity and what is the rate? We have to think about this. Now for this we have to go for the number of collector required. Now again, the identification of orientation of collector. As we all know, this solar thermal system depends on the location and the location. And that means the longitude and latitude on which, suppose when we are talking about at the western region, like in Rajasthan, the solar radiation is solar radiation is good. And when we talk about this Bihar and West Bengal, the radiation is little bit lesser than that compared to this Rajasthan. And when we are talking about this Leh and Ladakh, because there is no any humidity, so there again the solar radiation is great over there. Now again we are coming to the what will the overall space requirement for the complete system? Okay, what will the overall requirement for the complete system? Now again, we need to go for the identification of configuration, like either we need to series or parallel type of collector. Now again, finally we need to go for the performance evaluation of the collector, or we can say the entire solar thermal system. So this is the basic step for selection of a suitable collector or solar thermal system. Uh, this is all about this topic. I will discuss this air conditioning system, which require, as we all know, there are two popular air conditioning system. One is the vapor compression system, and second one is the vapor absorption system. So just and as we all know, these vapor compression systems are using very harmful refrigerant, but this vapor absorption systems are using environmental friendly refrigerant, and that can be operated by this solar energy. I will discuss in detail because the time is a factor. That is why I divided this presentation into two parts. This is part one for giving the idea on the basics and how to select a solar thermal system. This is all about the selection of this solar thermal system. Okay, thank you.
Okay, thank you, Professor Iqbal. So it was a nice presentation. So should I shoot the polls?
Yes, sir. Sure, sir.
So you have two polls. So maybe I shoot the first poll, the more efficient solar thermal system. So I launch it.
Yes, sir. Yes, sir. Okay.
So again, we will wait for 1 minute. I request all members to vote at your earliest, please.
Yes, sir.
We are into the 16th, 17th second. We have reached 43% votes. I request all members to vote at your earliest, please. We are already into the 35th second. We will wait for 1 minute. I request all members to vote at your earliest, please. Okay, so 52 seconds over. 4 more seconds to go, 58. So let me close it now. We have 56% votes. I close it and I will share the results. So the poll results are, as you can see, 72% goes for parabolic trough collector, 16% for flat plate collector, 9% both are having same efficiency, and 3% can't say. So yes, Professor Iqbal, your comments, please.
Yes, sir. The answer is correct. Correct answer is parabolic trough collector, because the flat collector is lesser efficient than this parabolic trough collector that I have already discussed in the presentation, and the correct answer will be the parabolic trough collector.
Okay, so 72% have gone with the correct answer, so we should be happy with that. So I go for the next poll. I have launched another poll. I request all members to again vote at your earliest, please. Again, we'll wait for maximum 1 minute. We are already short of time. I can see 1 or 2 questions in the questions box. I will try something new today. Every day I get some requests in the question panel to share the PPT, which often is not done. So I will try something new of sharing this PPT through this platform itself. Let me see whether it works. I will do that after 1 minute. So it's 39 seconds, 40 seconds rather. I request all members to vote at your earliest, please. Which of the following energy has the greatest potential among all the sources of renewable energy? Solar energy, wind energy, thermal energy, hydroelectrical energy. So it's 1 minute. We reached 53% votes now. So let me close it and share the results. I've shared the result. 84% goes for solar energy, 7% for hydroelectrical, 6% for thermal, and 3% for wind energy. So again, Professor Iqbal, your comments, please.
Yes, sir. The solar energy is one of the best form of energy by which we can produce all form of energy.
Yes,
So
what
correct
can be
answer
more
is the
powerful? What can be more
yes,
powerful than the sun? Definitely. Okay,
right.
so again, you will be happy that 84% have gone for the correct answer. I hide the results.
Yes,
I will go for the questions. Prior to that, I will try to share this PPT through this platform. Is
yes,
it being done? I don't know. Okay, so I don't think it is being shared. Did anyone get the PPT? Get the PPT over there in your computers? Can anyone please answer, please? Did you get any PPT from my side? Did anybody get any PPT from my side in this platform? If somebody can
yes,
answer.
sir. Yes, sir. I can see over here. It is afternoon meeting PPT like this. Should I download it or not? It is visible over here, but I cannot say other people are getting or not, sir.
Okay. So yes, there are answers like Professor Shatabdi Basu writes, yes, I can see in handouts. Thank you,
Yes,
Professor Shatabdi. Professor Ayun Chatterjee, got it, sir. Shoinik Kumar Mahata, yes, says yes. Professor Subhashish Rana, yes, sir. Dr. Umesh Dash, yes, sir, got it. So many of you are saying yes. So I believe that I tried to do this. because every day the PPT for sharing the PPT requests are there in the panel, but somehow we do miss most of the times. So I thought
Very
that
right.
this can be a way out. Okay, so I believe you can download. I don't know whether you can download, but at least you can see the PPT. That's the thing. So okay, so let me go for the somebody also do answer that whether you could download the PPT. If yes, please write yes, I could download. You can kindly write that in the questions box if you can write, because this is an experiment I'm trying to do. So try out. Yes, I can download if you can kindly write that. Anyway, so the first question, I'll go for it, Dr. Arnab Ghosh. In a solar
Yes,
thermal
sir.
system, how the heat dissipation from the receiver and storage systems is minimized? So, Professor Iqbal.
Yes, sir. By providing the appropriate insulator, we can minimize the heat loss. We have to think on proper selection of insulator.
Okay. Okay, so that's your answer. So I will go for another question from Professor Abhijit Kaur-Gupta. In fact, he says he has got two questions. So let
Yes,
me
sir.
firstly read out the first question. How fill factor or form factor can be enhanced? That's his first question. Second
Yes, sir.
question, Professor Kaur-Gupta, is this a question or I read it as a comment? Like it says, compared to European countries, our country
Yes,
is
sir.
lagging behind in the production of solar thermal energy, although we have enough area in Gujarat and Rajasthan to make more solar power plant. Okay, so
Yes,
maybe
sir.
this is a comment from your side and you wanted the comment of the speaker also. So Professor Iqbal, I request you to go for both the questions.
Yes, sir. As sir
How?
has, I'm talking about the
Yes.
second question, sir. As sir has very rightly pointed out, we have the enough space or enough area in Rajasthan or Gujarat or Leh and Ladakh, but but we are lagging behind, lagging behind after these European countries because the government initiative, as the solar thermal systems are having a very high initial cost, but the running cost after running, when it is run for just think about 5 years and 10 years, the cost will become minimized. The cost is reducing, but no investors are ready for investing this much of initial huge amount of money. Government should take the initiative regarding this for giving this some fund or running some pilot project like that, and that is very true, sir.
Okay. 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 So good. And the first question, fill factor or form factor, how can that
Uh,
be enhanced?
Film factor, sorry, sir, I cannot uh, tell on
Yes,
this.
yeah,
Yes,
okay.
sir.
Anyway, so somebody, okay, I will go towards the last.
Yes, sir.
Okay, Professor Gautam Ghosh says, I have downloaded the PPT. Smita Datta madam says, I have downloaded the PPT. Professor Indronil Basu sir says, yes, downloaded. Thank you. So it means many of you have said, yes, downloaded. Anupam Mandal sir has written, yes, downloaded. So I'm sure that it can be downloaded, and those who could not, I'm sure there is some way out. You can kindly discuss with the names that I mentioned: Dr. Shomi Gongopadhyay, Dr. Professor Anubhav Roy, Dr. Imran Khan, Dr. Manas Midya, Professor Arpan Garai. Everybody says that yes, it could download. Okay, thank you. Thank you. There is a comment from Professor Sumit Paul saying there is also coolant circulation to reduce the heat.
Right,
Okay,
very right.
okay, okay, okay. Thank you. I think that's all in the questions box as of now. So thank you, Professor Iqbal, and thanks to all IEM and UEM family members.
Thank
So
you,
we'll
sir.
meet
Thank you
again.
so much, sir, for
Thank
guiding me and for motivating me for this presentation. And thank you all IM and UEM family members. Thank you so much.
Okay, thank you. Thank you so much.